So in looking at number 16, we already got the squared by itself. Sorry, it's a little blurry here. So I want to go ahead and square both sides. That will give us x squared equals 42 minus x. Want to get everything to one side, so I like the square term to be positive. So let's go ahead and subtract 42 and add x to both sides. And when I rewrite this side, I'm going to put them in order ascending power. So I'm going to write the x squared term first, then the x, then the minus 42. And so now I'm looking at factors of negative 42 that add up to 1. Well, that would be negative 6 and positive 7. So that's going to factor into x minus 6 and x plus 7. Bring it up here. I want to go through and set each of those factors equal to 0 and solve. So the first one, I'm going to get x equals 6 if I add 6 to both sides. The second one, I'm going to get x equals negative 7 if I subtract 7 from both sides. Now, I need to go through and I need to check each one of these. So we're going to first start with the 6. We'll go back to my original equation, and I'm going to plug in 6. And sure enough, that gives me 36. Square root of 36 is 6. It does check. And then I need to check the negative 7. So again, go back to my original equation, replace x by negative 7. On the left side, we're going to have a negative 7. On the right side, 42 plus 7 is 49. Square root of 49 is positive 7. That doesn't work. So we have to throw out the negative 7. We're just going to keep the 6 as our answer. Now let's try number 17. Here I'm going to need to go and cube both sides. This gives me 3h plus 4 equals 5h minus 6. And let's get the h's on the right side. So I'm going to subtract 3h from both sides. Means I'm going to have to add 6 to both sides. That gives us 10 equals 2h. And then divide both sides by 2. And we shouldn't have to do the check here, but we can because it's an odd root. 3 times 5 is 15 plus 4 is 19, so that's the cube root of 19. 5 times 5 is 25 minus 6 is also 19, so that other side is also the cube root of 19. Let's take a look at number 18. So we want to solve. Here I'm going to do our substitution. I'm going to let u equals z squared. So that's going to give me a u squared plus 2u minus 8 equals 0. Looking for factors of negative 8 that add up to positive 2, that'd be negative 2 and 4. We'll go and set each of those factors equal to 0. So on this one, we need to add 2 to both sides. That gives me u equals 2. Here I need to take away 4 both sides. I'll need to take away 4 from both sides. That will give us u equals negative 4. Now remember that u is the same thing as z squared, so now I'm going to plug that back in. And then I'm going to use my square root property to solve for z. So here I'm going to get plus or minus the square root of 2. For the second one, that's going to be plus or minus the square root of negative 4, which we write that in terms of I. And then square root of 4 would be 2, so that would become plus or minus 2i. So our solution then would be negative 2i, negative square root of 2, and square root of 2. Okay, let's go to the next page. Let's take a look at number 19. So number 19, we can factor a greatest common factor of 3p. So that'd be p squared plus p minus 6 equals 0. You want to look for 2 factors of negative 6 that add up to 1. Well, that'd be 3 and negative 2. So that'd be p minus 2 times p plus 3. And now that we have factored, we want to set each factor equals 0 and solve. So 3p equals 0. Well, that's just going to give me, if I can write a 0 correctly, that's just going to give us 0 when I divide both sides by 3. For the second one, we have p minus 2 equals 0. We're going to add 2 to both sides. That gives us p equals 2. And then p plus 3 equals 0. We take away 3 from both sides. That gives us p equals negative 3. So my answers here are negative 3, 0, and 2. Now on this one, we see here we got 4 terms that screams out factor by grouping. So the first 2 terms have a w squared in common. My leftovers would be 6w plus 5. The last 2 terms have a common factor of 25, but since this is negative, I want to factor out a negative 25. So that would give us 6w plus 5. Now, each piece has that 6w plus 5 in common. Leftover is going to be w squared minus 25. But now that w squared minus 25 is the difference of squares. So we're going to go through, we're going to set each factor equals 0 and solve. So when we set the 6w plus 5 equals 0, we subtract 5 from both sides and then divide by 6. For the next one, we have w minus 5 equals 0. We add 5 to both sides. That gives us w equals 5. And for the last one, we have w plus 5 equals 0. I'm going to take away 5 from both sides. That gives us w equals negative 5. And then I'll put our solutions from smallest to largest. So negative 5, negative 5 over 6, and positive 5. So those would be our solutions.